Welcome to our lesson on analyzing code for security risks. Today, we'll dive into essential practices and methodologies to identify and mitigate security vulnerabilities within code. We'll cover various aspects, including secure code reuse, vulnerability databases, static and dynamic application security testing, manual code reviews, and runtime application security protection. Secure code reuse involves incorporating pre-existing secure code into new projects. This practice can save time and resources while ensuring consistency in security measures. The benefits of secure code reuse include increased efficiency, ensuring uniform security standards across applications, and utilizing thoroughly tested and proven secure code. To implement secure code reuse effectively, it's important to regularly audit reusable code for vulnerabilities, use version control systems to track changes and updates, and maintain comprehensive documentation for all reusable code. Vulnerability databases are repositories that catalog known security weaknesses and vulnerabilities. Key databases include the OWASP Top 10, which focuses on the most critical web application security risks, and the Common Weakness Enumeration, or CWE, which provides a detailed list of common software weaknesses. To utilize these vulnerability databases effectively, it's crucial to stay informed about new vulnerabilities, integrate vulnerability checks into the development lifecycle, and educate development teams about common vulnerabilities and how to avoid them. Static Application Security Testing, or SAST, examines code for security issues without executing it. This type of testing can be performed on both source and object code. SAST offers several advantages, such as higher code coverage than manual audits, early detection of vulnerabilities, and precise line-by-line feedback. However, SAST has limitations, including not testing in a real execution environment, challenges in deploying at scale, and the potential for many false positives. Dynamic Application Security Testing, or DAST, tests the application in a runtime environment, providing insights into its behavior under operational conditions. DAST offers advantages such as real-time analysis, lower false positives, and versatility in supporting various programming languages. Despite these benefits, DAST can only be done in later development stages, can be complex in pinpointing the exact error location, and is less effective for early-stage testing. Interactive Application Security Testing, or IAST, combines elements of SAST and DAST, using instrumentation to monitor applications in real time within the development environment. IAST provides early detection of vulnerabilities, detailed insights into the exact sources of errors, and integrates well into Agile and CI/CD pipelines. However, IAST tools can be more expensive to implement and operate, may affect application speed during testing, and the technology is not as mature as SAST and DAST. Runtime Application Self-Protection, or RASP, is a security technology that monitors applications during runtime to detect and prevent real-time attacks. RASP offers real-time monitoring, adaptability to respond to unanticipated inputs, and is suitable for critical applications. However, RASP can add significant complexity to the application, increase costs, and is generally reserved for critical applications due to these factors. Manual code reviews involve team-based inspection of code to identify vulnerabilities that automated tools might miss. The benefits of manual code reviews include multiple reviewers spotting different types of issues, promoting knowledge sharing and team skill enhancement, and encouraging the creation of maintainable and understandable code. To conduct effective manual code reviews, it's important to schedule regular reviews throughout the development cycle, use checklists to ensure consistency and thoroughness, and foster a collaborative, non-hostile, and educational review process. Common vulnerabilities and their countermeasures include injection attacks, such as SQL injection, which can be mitigated by ensuring proper input validation and using parameterized queries. Command injection can be avoided by not using user input directly in system commands. Cross-site scripting, or XSS, can be prevented using anti-XSS libraries and validating user inputs. Cross-site request forgery, or CSRF, can be mitigated by implementing CSRF tokens and validating session authenticity. Integer overflow can be avoided by using proper data type checks and exception handling. Path traversal attacks can be prevented by avoiding the use of user input in file paths and using secure path handling methods. By incorporating secure coding practices, utilizing both automated and manual code review processes, and staying informed about common vulnerabilities and their countermeasures, we can significantly enhance the security of our software applications. Regularly updating our knowledge and tools is essential in the ever-evolving landscape of cybersecurity. Thank you for joining this lesson on analyzing code for security risks. Stay secure.